Well, we're moving on to the next module where we're going to learn how we can make decisions in our programs. Here are the learning objectives for the module. So, I said we're going to learn about how we can make decisions in our programs. So what kind of decisions do we need to make? What does our program have to decide to do? So, here are some examples. We might decide, based on the user input, which direction we should move the player's avatar. So for example, if they're using WASD, then you want to move up with W and left with A and so on. So movement based on user input is one of the things we decide about. Another thing we decide about is when a collision has occurred. So we actually do some form of test to determine that a collision has happened. That's the detection part. So collision detection uses what's called selection, decision making, in our program. So let me back up for a moment and say the control structure we're talking about here is the selection control structure. That's what it's called because we're selecting between multiple courses of action in our program. Okay, so we use the selection control structure to detect collisions, and also we use it to resolve collisions. So the resolution of a collision may be based on a variety of different factors. Are we wearing enough armor that the rocket-propelled grenade bounces off when the collision occurs? Or do we not have that level of protection so that something else happens when that collision occurs? Okay, players do stuff in games, right? That's why they're fun to play. And based on the player's performance, say whether they're playing a mini game and they have to have a sort of minimal bar of performance, we can use selection to decide whether they get loot or not. So we might need to decide that. Players navigate menus in most games, and so based on their selection of which menu they want to go to, we might do that as well. By the way, menus, people do not get at all excited about writing menus, and virtually every single game you'll ever play has them. So it's one of the things that you'll end up doing as a game developer that is not nearly as exciting as some of the other things you do. You can actually build some really interesting menu systems if you choose to do so, but you're going to have to build them, just like tutorials, which has nothing to do with the selection control structure, but tutorials are another thing that people tend not to get too excited about, but everyone builds into their games. And lots more. There's lots more stuff that you might need to do in terms of deciding how your game performs. So you should go take an in-lecture quiz so that you can tell me about the statement we're going to look at today for doing that decision making. Okay, so this is a graphical representation of the if statement, and this graphical representation is what's called a control flow graph because it graphs how the control flows through the program. Looks something like a flow chart for those of you who have heard of such things. We don't tend to use these things as design mechanisms anymore, but we do use them to help visualize what the program will do. And so let's pretend, because we're going to do it soon, let's pretend that we're going to ask the player for some input. We're going to ask them a yes or no question. And if they answer yes, we want to print an appropriate yes message. And so this is sort of a picture of how that flow through the program would work. We'll ask them the question, and then we'll check their response. Let's put it in a variable called answer. And we'll check their response to see if it's equal to Y for yes. And if it is, we'll print that message. And if it's not, we won't. So those things, those edges, if you will, that come out of that top node are called branches. And so you should take an in-lecture quiz to tell me about what you understand about branches. And now you should go do another in-lecture quiz to tell me what you know about that answer equal yes part that we labeled the node with. So that expression, the answer equal yes, is called a Boolean expression. Remember, our Boolean variables can have values of true or false, and a Boolean expression is merely an expression that evaluates to true or false. And we use that result, the value it evaluates to decide whether or not we should do the thing, the branch, on the true side. Let's fire up the IDE. I already have a template built. You notice I remembered to zoom in this time. So we're going to look at some forms of the if statement. And so the first thing we're going to do is ask for and get an input from the user to a yes or no question. So we know how to ask for, we do a prompt. And let's give them something interesting to answer about. Pick up the shiny thing. And we'll tell them. They should tell us either yes or no. So there's our prompt. And then we're going to read this in. Now, this is a single character we're trying to read in. So let's call it answer. And I've declared it to be the char data type. And of course, I try to do a console.readline. And I get a compilation error that says I can't implicitly convert a string to a char. I've specifically chosen to put this into a char for two reasons. First of all, a character is the right choice, right? They're picking something with a single character, so we should in fact store it in a single character variable. The other reason I've decided to do it this way is because I wanted to show you that at this point, after this call to console.readline, we know we're holding a string of characters. A string, in fact, a string object. And we also know that we can access particular characters in that string by indexing using the square brackets. So I wanted to show you that we can take this call to the method and then add at the end square bracket 0 square bracket, and that will take that string object that the method returns and index into it to extract the 0th character in the string. So now we're holding the answer. Let's add that extra blank line that I like so much. And let's run it now before we actually add the if statement to make sure that's working properly. Pick up the shiny thing, yes or no. You'll notice that I can type a whole big long thing here, and it's just going to extract the D from the very beginning. We'll learn later that there are other ways that we could take care of this, but for now we're going to focus on the if statement, so we're going to let that happen. And that's the read line. Press any key to continue, so I have. So let's print an appropriate message. Let's print a message for the yes. So this looks much like the control flow graph, where I'll put a Boolean expression between the parentheses here. So if in fact the character the first character of the string they enter is in fact a lowercase y, then we'll print something. You have the shiny object. So now let's test our code. So we're going to try it with, we want to go down the true branch. So we'll make sure we enter a lowercase y. And we want to go down the false branch from that picture, which won't print any message at all at this point. Okay, so let's run it. And I'll just enter y. And I get the you have the shiny object. I'll run it again and enter anything other than y, like h. And I don't get that message, so that was the false branch. The only thing you might notice is that if I run this and I enter a capital Y instead of a lowercase y, because I've got caps lock on, because cruise control for cool, oh, I don't get a message, and it feels like I should. Right? So there are a variety of ways that we can do this. We can make sure that by the time we get to the if statement, we've capitalized or lowercased whatever character they entered. But I'd rather actually build a more complicated Boolean expression here to show you how that works. So we're checking if answer equals lowercase y here. And we learned that we have this OR Boolean operator. So we can check if it's lowercase y or uppercase y. And so that way, when I control F5, we'll try all three again. Y still works the way it should have. H still works the way it should have. But now when I enter a capital Y, I get that message again. So we've looked at the first form or variant of an if statement where we just have the if clause or the if block, this part right here. And we've built a not really complicated, but more complicated than just testing one thing, Boolean expression. So let's go back to the slides and look at another form where, in fact, if they say no, we can do something else. So at this point, we have both a print yes message along the true branch and a print no message along the false branch. So this is a pictorial representation of an if statement that has an else clause in it. So now we add the code for that. And we add the code by saying else and we'll write now, whoops, sorry, something really compelling: you don't have the shiny object. So now we have an if statement that will do this part if the Boolean expression evaluates to true. And if the Boolean expression evaluates to false, it will go do this part. So when we control F5, I'll test Y again. And I'll test N. Oh good, that's what it should have done. However, you might also realize that if we enter H, we still get you don't have the shiny object. And that may be acceptable for what we're writing right now. However, let's actually we're tired. We're tired of the user being a dork. And so we want to be a little abusive if they don't pick yes or no. Other than being mean to the player, there's a good reason for this because it lets me show you one more piece of the if statement. So let's actually say that we want the else to be something mean. You are a noob. And here we want to print the no message. What we can do is we can add an else if, and I will check both lowercase n and uppercase n, like so. And here's where we'll write, you don't have the shiny object. So, thinking about how this will work, what happens is when we're running this code, we get to this point right here. And we check the Boolean expression. If this Boolean expression evaluates to true, it will print this line, and then it goes all the way down here. So it goes all the way past this very last curly brace. If this evaluates to false, it goes down and checks this one. And if this one evaluates to true, it does this, and then comes all the way past the whole if statement. If neither this nor this evaluated to true, it'll come to the else and tell the user they are a noob. Let's try it. I pressed F5 and I crashed it because I just hit enter because the user is in fact a moron. So let me do Control F5. We'll check yes. Yes works fine. We'll check both lowercase n. Oh dear. It says we're a noob. So now we have this debugging thing, right? We have to go look at that Boolean expression and say, what's going wrong? And if we look at this Boolean expression, we can see that in my frenzy of typing, I said for this Boolean expression, if the answer is this is an and, not an or, I said if the answer is both lowercase n and uppercase n. And that is, in fact, impossible. So this should have been an or. See, even in a well-polished, well-prepared lecture, there can be mistakes, just like programming happens in general. That's why we're testing it. Okay, so I'll try the lowercase n. You don't have the shiny object. I'll try the uppercase n. You don't have the shiny object. And finally, I'll try my favorite not search for something. I'll try my favorite H. And I am, in fact, a noob. So that's it for the sort of different variants of the if statement. We looked at 3 different ways we can use this. We looked at an if that just has a true branch and nothing on the false branch. We looked at the if else, which has both true and false branches. And then we looked at adding else ifs as well, in case we have a more complicated sequence of Boolean expressions that we want to test. You should know once we start adding else ifs, we can add as many else ifs if we want, as we want, and the else part is in fact optional. We can just have if, else if, and that's it. And it will behave exactly as you'd expect. Next time, we're going to look, so that's it for today. Next time, we're going to look at another statement in C# that we can use to make decisions in our programs.